Alright, welcome back everybody. Going to start today by just looking a little bit more at containers. We have that container lab. Um, remember, it's just a vector that we're using, so we're going to include vector here. Like that. Should be good. And what the lab says is it wants you to make little rectangles that fall from the screen every 10 seconds. So we haven't learned about time too much. We've used it definitely in SFML to look at our frame rates, but we haven't used it other than that. So we'll look at that today and how to get these rectangles to drop from the screen. Okay. So to use time, SFML has a built-in variable type called clock, so I'll just call mine maybe C1 or something like that. Okay. There's not too many options you can do with C1. If you hit dot, you can get the time and you can restart the clock, and that's it. If you get the elapsed time, you can see that it's a time variable. And so there is a built-in time variable as well in SFML, and I never use it. I just I use the clock, and I'll show you how to do that. But time has a few commands that you can use on it as well. One is as seconds, one is as milliseconds, and one is as microseconds. So that's it. These two are ints, and this one's a float. It just returns the time in like the time amount that you want. Okay, so using that, we'll draw a rectangle on the screen every 10 seconds. And to do that, we'll just make a vector of rectangle shapes, a lot like we would have. We could use an array of rectangle shapes, but let me find out where the home key is there. So if I went rectangle shape and then maybe S, just call it S1 or S maybe, and then I could have 200 like that, 200 rectangle shapes. SFML wouldn't complain about that, either would C++. The only problem is I don't know if I'm going to need 200, and I'm going to need to add more to my array every 10 seconds, and then I'm going to need to know how many I actually have going to draw them and all that stuff. So it's a perfect reason to use the vector container. Just a little bit awkward to start it because you have to write the word vector, and then in pointy brackets you have to write rectangle shape. There's a bunch of other ones other than vector. If you want to see what they are, you can go to c++.com, I think. And under reference, you can go to containers here, and those are all the different ones that you can use. They all have their advantages and disadvantages. I like vector, but there is one called list, and one called queue, and one called DQ, and one called array, and one called map, and all kinds of ones. It's a little more advanced why you would use one over the other, but it has to do with how the memory is managed and the speed of it. Like if you're going to make an array that holds 5 million things, you'll want to use forward list because it's going to be faster than vector. If you need something to be able to erase in the middle of your vector, or in the middle of your array, you would use vector because it's really fast at like randomly accessing elements. Some of these you can't access the elements at all, just the front and the back elements, and that could be useful, etc., etc. So that's not our concern right now. So we do have a vector here, and it's empty. If I run my program, you will see that there's nothing in it because when I make it, I'm just saying I need a spot in memory, but I have not added anything to it yet. So you can see that it says vector of length 0, capacity 0. And C1, it has my start time in microseconds of some crazy number. That's actually probably the number that it grabbed from time 0, which we use to randomly shuffle our random numbers. Which we'll actually need too, because we're going to randomly put some rectangles on the top of the screen and hopefully get them to drop down, right? So I'll say stdlib, which is the library that contains the random function, and the other one I'll include is time.h. Okay, C++ does not include every function that exists to it. because that would be a lot of overhead. Every time you run your program, it adds all the code from these files to your code. Okay, let me just see if I can open this file. This file is pretty small, but it's got some includes in it. And if I open this one, I can see that it is 500, 600 lines of code, and the other one's probably a couple hundred lines of code, and the other ones. So when I add these includes, it's probably adding a couple thousand lines of code to my project. Okay. If I added every single function that C++ could use, I could be potentially adding 1,000,000 lines of code to my program every time I run it. So that's why we just include the stuff we need when we need it. Makes C++ run fast. Okay, so there we go. What do I want to do? Maybe at the beginning of my loop, I want to, every time the clock is bigger than 10, so I'm going to say if C1 dot get elapsed time is bigger than 10, then I want to add a rectangle. The only problem is this won't work because it says this is a time variable. So if I hit dot like this, get elapsed time, and hit sorry, let me just go back and show that to you a little slower. Get elapsed time. It says it's a time variable. Well, C++ doesn't know anything about SFML's time variables, so it won't know how to compare it to the number 10, and it probably will crash with a very big error message. It actually tells you a little bit that it has a hard time converting int to SF time. So what I want to do is I want to pick, I'm just going to hit dot because I know time has a bunch of different commands, and I could say as seconds maybe, and I could say it's bigger than 10. And then it'll know how to compare it, right? So let me just maybe see out the word hello on the screen or something. Something simple like that. Every 10 seconds it should say hello. This is bad YouTube video though. It's 10 seconds gone by there, it says hello. Perfect. Okay. Watch if I say 1 second. Not only am I going to say hello, but I'm going to restart my clock so that it, so I'm going to hit clock c1.restart, and now it'll reset the clock back to 0, and then so every 1 second my console should say the word hello. 1, 2, 3, 4, 5, 6, 7, 8. You get the idea, right? So that's how I control time in the game. But I want to say 10, and I want to keep my restart in there. And after 10 seconds, what I want to do is I want to go s dot push back. That's the command to add a item to my vector. Okay, and I'm adding a rectangle shape. Oops, rectangle shape. Now I believe I have to put empty brackets in there. If I don't, it won't work. Great. So every 1 second now I'm adding a rectangle shape to my vector. If I don't put brackets here, I think it messes up. Yes, it does. It's waiting to see brackets after the word rectangle shape. Okay, no problem. All right, so every 1 second now I'm adding a rectangle shape. Remember, of 0 size and at the point 0, 0. So I'm going to go like this. I'm going to go s dot. Now there's a command called back, and it returns the reference to the data at the last element of your vector. So that is going to be the one I just pushed onto the back of my on my vector, and then I can do anything I want with it. Like it sees it as a rectangle shape, so it has all the commands that exist for an SFML rectangle shape. So I want to set the size. Set size. It's the command. And again, it takes vector 2f. I might go into the code and change the fact that it only takes vector 2f and not 2 floats. Okay, so I'm just going to make it 10 by 10. I'm also going to continue to grab that back one and set its position, right? Now I can give set position 2 floats, so I'm going to give it a random number between 0 and 800, so that it'll just be, I might do 0 and 790. Just because it's 10 wide, so I don't want it to go off the screen. There's no point in that. It'll give it a Y position of 0. So every second it's going to, every 10 seconds, I'll speed it up a little bit because, so the video's not, we don't have to wait 10 seconds in our video. So there you go. Every second, every 5 seconds, I'm adding a rectangle, and not only that, I'm taking the one I added, setting its size, and setting its random position. So then here, if I want to draw them all, I make my for loop, int I equals 0, like that. And I do I is less. Now, I don't know how many I have. After, after 25 seconds, I'm going to have 5 of them. And after 30 seconds, I'm going to have 6, and so on and so forth. But vectors, if you remember, have a variable or keep track of their own size. So I'll write s dot size and then I plus plus. And I don't need curly brackets because I'm just calling one command, which is to draw my rectangle. Now, if I hit S here, it won't work because S is a vector of rectangle shapes, right? I need the square brackets with the I, which says draw each one individually. So every 5 seconds, I should get a rectangle on the top of my screen. Any luck? I don't see any. Oh, there we go. There's one. It's kind of weird. I want to make it a little faster here. 3, 4. There you go. You see them all drawing at the top of the screen. 10 by 10 might be a little bit small, so why don't I do 30 by 30? Okay. There you go. Random rectangles at the top of the screen. Now, and I could say 770 here, so that they don't go off the screen. Okay, how could I make them fall? Right before I draw them, I could just move each one in the Y direction. So maybe I should put a curly bracket here. I already have a for loop that's going through all of my rectangles, right? And I'll say end. And I could do something like SI, which is all of my rectangles, and just say move. And then I don't want it to move in the X position, but I want it to move down 5 pixels in the Y direction or something like that. So every second now, it should rain rectangles. There you go. Neat, eh? Now, and I could do it faster as well, right? I could do like 0.1 here, and then it falls kind of like, it's raining rectangles. Or you could get it to do it 60 times a second, and just put if it's greater than 0. Then every frame it'll run. Looks pretty crazy. Let me just output on the screen how many rectangles I have so that I know, because in the lab it asks you to delete them. So, and there's a trick to doing that too. So what you do is, there, I have 1, now 2, 3, 4, right? Here's the problem though, they're still in the memory, right? So if I ran this program for 1,000 seconds, I'd have 1,000 of them, even though I don't need them anymore and they're all off the screen. Okay, so how are we going to erase it? How are we going to erase a rectangle if it falls off the screen? Well, the first thing we're going to do is just, maybe we should do a for loop. Could we do it in here, I wonder? Window.draw. Maybe after the, you know what I'm going to do? I'm going to do it at the beginning of my while loop. I'm going to go through my rectangles. It's probably not the most efficient way to do it, but we're running such a small program that our computer can definitely run it 60 times a second. Okay, so there we go. I'm going to go through all of my rectangles and just make sure that, by the way, look at this, right? Watch, this is really messed up. If I write size +1, I don't get an error. And with arrays, you wouldn't get an error either. But with arrays, your program would run and just like do unexpected things. But if I run this, I think my program, does it crash? No, interesting. let me just go see out. Or let me try to access an S that doesn't exist. Like, let's say I try to go SI, right? Dot set fill color, and then I want it to be red. This would work. It would make them all red if this didn't have a +1, because if there's like 15 of them, it'll try to set the color to the 16th one. And what usually happens, the program just crashes and gives you like a weird return value. But it doesn't tell you where it crashed or what made it crash. That's one of the problems with vectors that I don't like, is that it doesn't give you any error message if you try to access one that doesn't exist. And it's really easy to do that. It just crashes your program. The way I usually try to catch those kinds of errors is I put a stop sign right here, right at the end of my program, and I hit debug, and it'll usually tell you what line it crashed on. Okay, look at the message I get. It crashed on a line 23 of main. Okay, right there. That's interesting that it's looking in there for something. I don't think that exists anymore. But right here, it crashed on line 23. So I know there's something wrong with this line, and then I can go back and say, oh, I tried to access one extra one that didn't exist. Okay, so I'll stop my debugger, and that is how sometimes we can catch mistakes. Memory leaks, they're called. There, it's making them red, no problem. Okay, but I did want to figure out how to erase them, and I'm going to do that right now. So I'm going through this loop of all of them. I'm going to say if the Y position of any of these is ever bigger than 600, so I have to go si.get position dot Y. If that's ever bigger than 600, what I want to do is delete it. Okay, so here's how I'm going to delete it. I'm going to go s.erase, right? Okay. And then in brackets, it says it's looking for the position of the one you want to delete. And it would be great if I could just put I, because if the third one is bigger than 600, I want to delete the third one, right? And I is keeping track of which one I'm checking. But it doesn't work like that, unfortunately. What you have to write is s.begin plus I. S.begin is the memory address. Is that how you spell address? It looks weird. Is the memory address of the first element. Okay? And so it needs that memory address of the first element. If you just say 3, it doesn't know to like grab the third one. It needs to know where it starts. And then, which is weird. You would think by default they could just add that inside, but you know, maybe, you know, other people are using erase for other things. Okay. So that should erase it. And should just be gone from our vector. And then as I draw, I have 1, 2. Notice how it's not going up. It's only ever keeping 2 on the screen, and I'm not going up by too many. Let's see what happens if I put greater than 0. I should draw about 60 a second, and let's see how many it can throw on the screen. It's maxing out at around 121. So it's taking about 2 seconds for it to fall down. Does that make sense? 2 seconds? Yes, it does. I am running my game, my project, at 60 frames per second, which means it's got to fall 10 pixels every frame to go down 600 pixels. And I'm only moving 5 pixels down, so it should take about 2 seconds to fall to the bottom of the screen. And in that 2 seconds, I can draw 120 or so before they start deleting. So that's much more efficient, right? I have 120 at all times, and I'm deleting them, as opposed to getting rid of that erase command and eventually having your computer explode because I now have 300 of these in memory, 400, 500. That's going to be expensive to keep filling up the computer's memory with stuff you're not even using. Okay, so that is how you do vector erasing, and you can incorporate graphics into it. You could even make this, instead of a rectangle shape, make this a text and a font that you load in, and then instead of the rectangles falling down, you could have random letters, right? And that would be the matrix screen. You could go even faster too, right? If I keep my erase command, but I disengage my frame rate, you'll see how fast it can go. It's starting to look really cool. It's like pixel art, okay? But if you did all that as fonts, or even instead of just adding one per frame like this, you could copy this line twice. I could copy all of these lines twice, and now I'm drawing 2 random ones per frame. So I should have around 240, right? Yeah, and I get more. So play around with that today. See what you can do. It is our last week of school. We have Thursday and Friday. I'm going to post a assignment 4, but I don't know if I'm going to mark it. What it is if you look here, it's create a gallery shooter type project with a main sprite that is able to shoot projectiles at a group of targets on the screen. Your game will be created on the use of SFML time, use of vectors to create and erase, and creativity and presentation. With all this stuff here, you can make like a pretty cool little 2D game where you can erase vectors of pictures or sprites or whatever you want. You can also use the mouse or the keyboard to control them. If we were in class, we would spend some time making something fun like that. If you're interested in all of this stuff and you think it's kind of fun, just try to make something cool, okay? But I won't mark it just because I know not everyone has the resources to do that, especially working from home. And let me know if you have any questions. I think tomorrow and Friday we'll just call them catch-up days, where you can all be grading your stuff and you can see what you're missing and what to hand in, and keep an eye on the grade in your course. I'm starting to set all the weightings of all the projects so that they match up to what they say in the course outline, and yeah, the labs are going to be a big component of the mark. Okay, so work away at that today. Let me know if you have any questions by emailing me through the school's Gmail. That's the best way to get a hold of me, and then I can help you through any problems you have as well. Okay, thank you for watching. Bye.